discrete and continuous random variables. Our objective? To distinguish between discrete and continuous random variables. So what do we know coming in? We know that quantitative variables are variables that provide numerical measures. And there are two types of quantitative or numerical data. You have a discrete variable. It's a quantitative variable that has either a finite number of possible values or a countable number of possible values. A discrete variable cannot take on every possible value between any two possible values. If you count to get the value of a quantitative variable, it is discrete. Okay, 1, 2, 3, etc. And there's no such thing as 1.5 or 1.2 or 2.76. Okay, the second type of quantitative variable is continuous variable. A quantitative variable that has an infinite number of possible values that are not countable because there's an infinite possibility. You can't count them. A continuous variable may take on every possible value between any two values. If you measure to get the value of a quantitative variable, it is continuous. So if you're counting to get the value, it's discrete. If you're measuring pounds, for example, seconds, for example, it is continuous. Okay? Let's define random variable, a numerical measure of the outcome of a probability experiment. Its value is determined by chance. Typically, a random variable is denoted using capital letters like X. And there are two types of random variables. Go figure, discrete and continuous. A discrete random variable is a random variable that has either a finite or a countable number of values. We find those by counting. A continuous random variable is a random variable that has an infinite number of values. We find continuous random variables by measuring. All right, so we're just going to look at a couple of examples. Is it discrete or finite? Determine whether the random variable is discrete or continuous. I misspoke there. In each case, state the possible values of the random variable. Okay, letter A. The time it takes for a light bulb to burn out. Well, time is something we measure. We measure time. We might use a stopwatch, for example. Okay, we measure time. How long did it take? We're going to measure that. So this is a continuous random variable. Okay, and the possible values. Okay, anything greater than or equal to 0, right? It could be 0.001 seconds. It could, depending on how we're measuring it, seconds, minutes, hours, it's obviously not going to be negative. I hope it's not 0. Maybe it does burn out as soon as you turn it on. But we're measuring that. And if we were to say counting 1 second or 2 seconds, well, how about between 1 and 2, 1.5? How about between 1.5, 1.25? So there are an infinite number of values as we talk about this. You can get finer and finer values as you're measuring the time it takes a light bulb to burn out. Letter B, the number of free throw attempts before the first shot is made. Well, we're counting that. We're not measuring free throw attempts. There's no measuring device. We're counting. So this is a discrete random variable. And obviously we're going to be what? We're going to have our set is going to start with 1, and it's going to go along like this. It's going to go along that way. It might take 1 attempt. It might take 2 attempts. It might take 3 attempts. It could take 1,000 attempts to make your first free throw, your first shot. What we know is there's no such thing as 1.5 attempts. You don't make your free throw on the first and a half attempt. No such thing. It's either the first attempt or the second attempt. So we're counting, and there are a finite, in this case, it's not finite, it goes on forever, but it's countable. Hence the finite or countable number of values here. So there you have it. We're obviously going to be working with this stuff as we move forward with probability and some various distributions. Continuous random variable, you measure it. Discrete random variable, you count it.